Welcome to Module 3. In this module, we'll talk about the principles of adaptation to stress, such as the SET principle, the FIT principle, and the principles of progressive overload and reversibility. You'll also learn to apply these when designing a training plan. In upcoming modules, you'll get to apply these principles to cardiovascular fitness, to muscular strength and muscular endurance training, and also flexibility training. The human body adapts well when it's exposed to stress. The term stress within the context of exercise is defined as an exertion above the normal everyday functioning. The specific activities that result in stress vary for each individual and depend on a person's level of fitness. For example, a secretary who sits at a desk all day may push his or her cardiorespiratory system to its limits simply by walking up several flights of stairs. However, for an avid runner, resistance training may expose the runner's muscles to muscular contractions the athlete is not accustomed to feeling. So although stress is relative to each individual, there are guiding principles in exercise that can help individuals manage how much stress they experience to avoid injury and to optimize their body's capacity to adapt. Knowing just a little about these principles provides valuable insights needed for organizing an effective fitness plan. The SET principle simply states that to develop a particular fitness or skill component, you must perform exercises that are specifically designed for that activity. Although this model is dedicated to cardiovascular fitness, I want to give you an example of what the SET principle looks like when you take into consideration all of the components of physical fitness. So let's take a runner, for example. To get better at running, we should, of course, run. But we can throw in a couple of days of swimming or cycling to continue to strengthen our cardiorespiratory system without the high impact of running. We could also look at strength exercises to increase the strength and endurance of not only the muscles in the legs, but hips and core as well. And then along with cardio and strength training, we can add some dynamic movements to help with the flexibility part. We can also add some drills such as high skips and A skips to add that skill-related component. And lastly, and this happens naturally when people start a running program, our body composition is going to improve because, well, we're losing body fat and at the same time gaining some muscle mass. Consider the old saying, no pain, no gain. Does exercise really have to be painful, as this adage implies, to be beneficial? Absolutely not. If that were true, exercise would be a lot less enjoyable. Perhaps a better way to relay the same message would be to say that improvements are driven by stress. Physical stress, such as walking at a brisk pace or jogging, places increased stress on the regulatory systems that manage increased heart rate and blood pressure, increased energy production, increased breathing, and even increased sweating for temperature regulation. As these subsequent adaptations occur, the stress previously experienced during the same activity feels less stressful in future sessions. As a result of the adaptation, more stress must be applied to the system in order to stimulate improvements, a principle known as the overload principle or the principle of progressive overload. For example, a beginner weightlifter performs squats with 10 reps at 150 pounds. After 2 weeks of lifting this weight, the lifter notices that the 150 pounds feels easier during the lift and afterwards causes less fatigue. The lifter adds 20 pounds and continues with the newly established stress of 170 pounds. The lifter will continue to get stronger until his or her maximum capacity has been reached, or the stress stays the same, at which point the lifter's strength will simply plateau. The same principle can be applied not only to gain muscular strength, but also to gain flexibility, muscular endurance, and cardiorespiratory endurance. So take into consideration the self-assessment tests you did for the last module. The scores you received on those tests provide a good starting point for your cardiovascular fitness plan. In exercise, the amount of stress placed on the body can be controlled by 4 variables: their frequency, intensity, time or duration, and type. This principle is better known as the FIT principle. The FIT principle, as outlined by the American College of Sports Medicine, falls under the larger principle of overload. Each of the variables can be used independently or in combination with other variables to impose new stress and stimulate adaptation. Such is the case for frequency and time. Frequency relates to how often exercises are performed over a period of time. In most cases, the number of walking or jogging sessions would be determined over the course of a week. A beginner may determine that 2 to 3 exercise sessions a week are sufficient enough to stimulate improvements. On the other hand, a seasoned veteran may find that 2 to 3 days isn't enough to adequately stress the system. According to the overload principle, as fitness improves, so must the stress to ensure continued gains and to avoid plateauing. The duration of exercise, or the time, also contributes to the amount of stress experienced during a workout. Certainly, a 30-minute brisk walk is less stressful on the body than a 4-hour marathon. Although independent of one another, frequency and time are often combined into the blanket term volume. The idea is that volume more accurately reflects the amount of stress experienced. This can be connected to the progression principle. For example, when attempting to create a jogging plan, you may organize 2 weeks like this. Week 1, 3 days a week for 30 minutes per session, and week 2, 4 days a week for 45 minutes per session. At first glance, this might appear to be a good progression of frequency and time. However, when calculated in terms of volume, the aggressive nature of the progression is revealed. In week 1, 3 days at 30 minutes per session equals 90 minutes of total exercise. In week 2, this amount was doubled with 4 days at 45 minutes equaling 180 minutes of total exercise. Doing too much too soon will almost certainly lead to burnout, severe fatigue, and sometimes injury. The progression principle relates to an optimal overload of the body by finding an amount that will drive adaptation without compromising safety. Intensity, the degree of difficulty at which the exercise is carried out, is the most important variable of the FIT principle. More than any of the other components, intensity drives adaptation. Because of its importance, it's imperative for those beginning a fitness program to quantify intensity as opposed to estimating it as hard, easy, or somewhere in between. Not only will this numeric value provide a better understanding of the effort level during the exercise session, but it will also help in designing sessions that accommodate individual goals. How can intensity be measured? For cardiorespiratory fitness, heart rate is one of the best ways to measure a person's effort level. If you are unable to measure your heart rate, you can use the RPE scale. When you're lifting, you can use a percentage of maximum lifting capacity to measure how hard you're working. So simply put, the type of exercise performed should reflect a person's goals. In cardiorespiratory fitness, the objective of the exercise is to stimulate the cardiorespiratory system. Other activities that accomplish the same objective include swimming, biking, dancing, cross-country skiing, aerobic classes, and many more. As such, these activities can be used to build lung capacity and improve cellular and heart function. However, the more specific the exercise, the better. While vigorous ballroom dancing will certainly help develop the cardiorespiratory system, it will unlikely improve a person's 10K time. To improve performance in a 10K, athletes spend the majority of their time training by running, as they will have to do in the actual 10K. Cyclists training for the Tour de France spend up to 6 hours a day in the saddle, pedaling feverishly. These athletes know the importance of training the way they want their body to adapt. This concept, we already talked about it, is called the principle of specificity or the SET principle, and should be taken into consideration when creating a training plan. So here you can see an example of a basic running plan I created for a client a few years ago. His goal was to run a half marathon sometime in October of that year. On the left, you see a simple overview that I created at the beginning for planning purposes. You can see how I incorporated the principle of progressive overload by increasing the weekly mileage only by a few miles per week. On the right side, you see a weekly plan that goes into a bit more detail as far as running pace. Over the course of the next few months, this client was increasing his running pace during these runs as well. So when you create your plan for this module, you can use any mode of cardiovascular training such as swimming or cycling. You can also utilize anaerobic training to create your plan. Chronic adaptations are not permanent. As the saying goes, use it or lose it. The principle of reversibility suggests that activity must continue at the same level to keep the same level of adaptation. As activity declines, called detraining, adaptations will decline as well. In cardiorespiratory endurance, those key areas such as the VO2 max, stroke volume, and cardiac output all decline with detraining, while submaximal heart rate increases, so that resting heart rate comes back up. In one study, trained subjects were given bed rest for 20 days. At the end of the bed rest phase, VO2 max had fallen by 27%, and stroke volume and cardiac output had fallen by 25%. The most well-trained subjects in the study had to train for nearly 40 days following the bed rest to get back into pre-rest conditions. In a study of collegiate swimmers, lactic acid in the blood after a 2-minute swim more than doubled after 4 weeks of detraining, showing the ability to buffer lactic acid was dramatically affected. Not only is endurance training affected, but muscular strength, muscular endurance, and flexibility all show similar results after a period of detraining. So keep at it. So in this module's discussion post, you'll be given a scenario to which you'll be able to apply the principles you just learned about. Be sure to use the materials from this module's lecture, as well as the readings to develop a plan. In addition to your initial post, please comment on at least 2 of your classmates' posts.